Let's continue our discussion about bisection method. So let's solve x to the 3 plus x minus 1. Okay. So again, bisection method will need to determine the upper and lower limit. Upper will give us a positive result when we substitute it to our equation, while x sub l will give us a negative result when we substitute x. And then after getting x sub l and x sub u, we get the x sub m, which is the midpoint of x sub n and x sub u, and then substitute x sub m to our equation. And if it's positive, we're going to replace x sub m, x sub u by x sub m. But in case if it's negative, we're going to replace x sub l by x sub m on the next iteration. To determine if we're going to stop the solution, we're going to compare the error of our solution to the desired error or acceptable error. If it's greater than, we're going to continue the iteration. If it's less than or equal, we stop. Okay, so let's go back to our equation, x cubed plus x minus 1. So in the problem, the range was the range is already been given, which is 0 and 1. So we need to test first, which is the lower and upper x. Okay, so let's consider 0 as your lower x. So when we substitute 0 to our equation, it should be negative, so that it will be negative rather, so that it will be considered as x sub l. Okay, so 0 cubed plus 0 minus 1 is negative 1. So correct. It will be considered as x sub l. While for x sub u, okay, so we're going to substitute 1. So 1 cubed plus 1 minus 1 is 1. So therefore, your x sub u is 1. And the error, acceptable error, is 0.01% for this problem. Okay, so after determining x sub l and x sub u, we determine the midpoint, which is 0.5, and then substitute it. We have negative result. So therefore, on the next iteration, we're going to replace x sub l by x sub m, okay, and then retain x sub u, and then get the new x sub m, substitute our equation, and we have the result. Since we already have 2x sub m, so we could get the error based on the relative absolute error formula. Okay, and since this is greater than the error, the acceptable error, we're going to continue. Okay, so what to replace? X sub l or x sub u? So based on the function x, it should be x sub u since this is positive. Okay, so the new x sub u will be 0.75. Okay. So wait, I'm just going to copy my equation. So it's 0.75. Get the midpoint. We have 0.625, and the new function is the new result is negative, and the error is still greater than. So continue this solution until you stop. Okay, so based on this, after on the 14th iteration, we're going to have 0.01% error, which is equal to the desired error. Okay, so this will be the result, that this will be the root of our x, one of the root of our x. Okay, 0.6823. But in case you want to get the other points, so you could change the range. So you could do 500 here. Okay, if we're going to get have a bigger range, definitely you're going to have more steps. Okay, until we get the desired result. As you can see here, we're getting the previous result, but more than the more that step are more than the previous steps. Okay, so let's move on with another example. X cubed plus 5x minus 5. Okay, just going to remove this. Okay, now, so first step, determine your x sub l and x sub u. X sub l, so it should give us a negative result. Let's suppose 0. So it will give us negative 5. And for x sub u, I'm going to use 1. So it will give us positive 1. And the error is 1%. Okay, so after determining your x sub l and x sub u, get the x sub m by getting the midpoint, and then substitute to our equation. If it's negative, replace x sub l. If it's positive, replace x sub u. Since this is negative, replace x sub l by x sub m on the next iteration. So on the second iteration, we have 0.5 for the x sub l, x sub u is still 1, and x sub n is 0.75. Okay, and then substitute, we have negative, so it means we're going to replace x sub l on the next iteration since the error is still bigger than the desired error. Okay, and then get the midpoint. Since this is positive, on the next iteration, we're going to replace x sub u. X sub l is retained since error is more than 1%. So continue this until we get 1% or less than 1% for your error. Okay, so where it is dito sa 7. Okay, so this is our answer point 8675 that yields a 0.9% error. Okay, so that's bisection method. So that will be my last example for bisection method. If you have some question, kindly send me a message. Thank you.